Very good morning to everyone, ma. Actually, on 10th November, I have been tested positive for COVID-19. That is why I could not take live classes these all days. Okay. Still, I'm feeling tiresome and feeling very weak. Okay. So whenever I feel, I take live classes. Otherwise, I will send you the video lectures. Okay. Please go through without missing. And today we are going to discuss the paper, yesterday's paper. Okay. Just a moment. Yeah. So the first question of yesterday's paper was a sample of air contains what nitrogen, oxygen, and saturated with water vapor. So the air contains what here? Nitrogen gas, oxygen, N2 gas, O2 gas, and some water vapor. Okay. So under a total pressure of what? 640 mm. 640 mm is what here? 640 mm is the total pressure of the gaseous mixture. What is here? Total pressure of the gaseous mixture. This one remember here. P total. P total of which gases here? Which gaseous mixture? Nitrogen gas, oxygen gas, and saturated water vapor. Means water vapor plus O2 plus N2. These three gases together, what mixture now here? For the total mixture, what is the pressure? Total pressure of the mixture 640 mm is given. Okay. So partial, Dalton's law of partial pressures, we have to recall once. Okay. Next, if the pressure of the water, if the pressure of the vapor pressure of water is given 40 mm here. So what is given here to you? 40 mm is what now? Aqueous tension. Aqueous tension meaning what? The pressure of water vapor. The pressure of water vapor at a given temperature is called what? Aqueous tension in air. So the aqueous tension is given. Partial pressure of water vapor is given in the mixture of much? 40 mm. And the molecular ratio of N2 and O2 is given 3:1. That means what? 3:1 is the molar ratio, molecular ratio. So molar ratio is given and partial pressure of nitrogen is asked to calculate. What is the partial pressure of any gas? Partial pressure of nitrogen gas formula what generally? Partial pressure is equal to mole fraction into total pressure. Partial pressure of nitrogen gas is equal to what? Mole fraction of nitrogen into total pressure. Okay, that is the formula for what? Nitrogen partial pressure. So first of all, we have to understand that this total mixture initially contains what now here? Nitrogen, oxygen plus water vapor. That means what now? Nitrogen plus oxygen together what? Dry gas here. Nitrogen plus oxygen together what? Dry gas. Plus some water vapor, moisture is there here. So dry gas is there, dry gas pressure is there, plus water vapor pressure is there. Dry gas is nothing but nitrogen plus O2. And water vapor is what now here? Aqueous tension. So the moist gas pressure is equal to what formula generally? According to Dalton's law, moist gas pressure is equal to dry gas pressure plus pressure of water vapor. The pressure of water vapor is called aqueous tension. So from that concept, we have to understand here. This now. Now, initially, what is given? Partial pressure of nitrogen plus partial pressure of oxygen plus partial pressure of H2O is equal to how much here? 640 mm given. Total pressure is given. Gaseous mixture. Next, partial pressure of water vapor, that is aqueous tension, is given how much? 40 mm. Right, ma? Now, the dry gas pressure, it is dry. Dry gas pressure is equal to what? Moist gas pressure minus pressure of water vapor. Moist gas is nothing but a mixture. This mixture of three gases is what? Moist gas. The moist gas pressure is how much here? 640 minus pressure of water vapor is given already to you. So now this will give what now? 640 moist gas pressure of moist gas minus pressure of water vapor is equal to 600 mm. Now 600 mm is equal to what now? The sum of the partial pressures of nitrogen gas and oxygen gas. PN2 plus PO2 together what? 600 mm. Now this 600 mm is what? The total pressure of gaseous mixture of only nitrogen and oxygen, remember. 600 mm is the total pressure of the gaseous mixture of nitrogen gas and oxygen gas. These two gases together, how much total pressure? 600 mm, remember. And so next one, what now? number of moles of nitrogen to oxygen, the ratio given what? Molar ratio given what? 3:1. Molecular ratio is nothing but molar ratio. So here nitrogen and oxygen given what? No, 3:1 ratio given molar ratio. Okay. Now here partial pressure of nitrogen or any gas is equal to what? Mole fraction of that gas, mole fraction of nitrogen gas into total pressure of this mixture. This total pressure must be taken what here? This 600 mm should be taken. It is total gas pressure. Okay, we should not take 640 mm here. Remember, it is not 640. It is only 600. Okay, next. So the partial pressure of nitrogen is equal to what? Mole fraction formula what? Number of moles of nitrogen divided by total number of moles of two gases. In the dry gas, which two gases there? Nitrogen is there, oxygen is there. Na? So the number of moles of nitrogen gas divided by total number of moles. It is mole fraction of nitrogen into total pressure, that is 600 mm. So we get now number of moles of nitrogen, how much? 3 divided by 3 plus 1. 1 mole oxygen, 3 moles nitrogen, total moles 4. So 3 by 4 into 600 will be 450 mm. Okay, so this is what now here 41, question number 41. So 450 mm. Next, in the second one, two bulbs given. A bulb, hydrogen bulb, nitrogen bulb. Okay, so these two are connected with one valve, connected by a valve. And here initially the hydrogen bulb volume how much? 0. liters. And what is the pressure of hydrogen gas in bulb A? 2 atm. In bulb B, nitrogen gas is there with 0.2 liters volume and 1 atm pressure. Now the total pressure observed after opening the stopcock. So the stopcock, when you open, what happens is hydrogen and nitrogen, both gases will intermix with each other. Okay, after opening the stopcock, and what is given in the bracket? Neglecting the volume of tube containing the two bulbs. Okay, this tube is there, na? Connecting the two bulbs. This volume you take negligible volume. That means need not to consider. Now the total volume will be equal to what? This 0.1 liters plus 0.2 liters you can take directly. So neglect the volume of the connecting bulbs. Okay. So now what they ask? The total pressure observed they ask here. Total pressure observed. Now see here. So now the two bulbs here, volume V1 and V2. P1, P2 given to you. Okay. So now here, whenever you connect, initially here P1, V1 for this P2, V2. After mixing, what happens now? Total volume will be what now? Total volume after mixing V1 plus V2, total volume. And P total, V total, that one, V1 plus V2. And P total we have to get. P total we have to get. So what is the formula here? P total into V total. P total into V total is equal to P1 V1 plus P2 V2 actually. What is the original formula here? P total, total pressure after mixing, into V total, total volume after mixing. So P total into V total is equal to what? P1 V1 plus P2 V2. From that we have got P, total pressure after mixing, is equal to P1 V1 plus P2 V2 divided by total volume, that is V1 plus V2. So we get 1.33 atm here. Okay, ma. Next, 43. For an ideal gas, a plot means a graph of PV by RT versus temperature. So PV by RT, this ratio is taken versus what? Temperature is taken here. So will look like what? So what is PV by RT from ideal gas equation? PV is equal nRT, we know. Then N is equal to what? PV by RT. PV by RT is nothing but N only, na, number of moles only. Number of moles versus temperature, meaning here. PV by RT meaning what? Number of moles. N is equal to PV by RT according to ideal gas equation. So number of moles versus temperature graph they ask here. Okay. So for an ideal gas, the number of moles and temperature will be independent. That means what now here? Initially, suppose you take 1 mole of gas. 1 mole of gas, if you heat from T1 temperature to T2 temperature, 1 mole will remain 1 mole only. Number of moles remain. Number of moles will remain what? Same. So number of moles will not change when you increase temperature. Just volume will change and pressure will change with temperature. But number of moles remains what? Number of moles will remain constant. That's why what here? PV by RT. PV by RT means number of moles versus temperature will be independent. Na? So here, this will be a straight line parallel to x-axis. Straight line parallel to what? X-axis we get. So PV by RT is nothing but number of moles. Number of moles versus temperature will be this one, option 4. Next, at 380 mm pressure, and 0 degrees Celsius. Whenever temperature is mentioned in centigrade temperature, we have to convert into what? Kelvin temperature. So 0 plus 273. So 273 Kelvin temperature here and 380 millimeter pressure here. Is it clear, ma? So number of moles of the gas present in 11.2 liters, 11.2 liters of it. So volume is given here and temperature T is mentioned 273 Kelvin you take here and 380 mm pressure is given to you. 380 mm pressure is given. So what is asked here? The number of moles they asked. What is the formula for number of moles, ma'am? Number of moles formula what? PV by RT. PV by RT. See here now pressure is mentioned how much here? P is equal to 380 mm. So convert into ATM here. We know that 760 mm is equal to 1 ATM. Therefore, the given mm by 760 will be equal to some ATM. So pressure in ATM you take first. Next temperature in Kelvin we have take 273 Kelvin. 273 Kelvin is temperature given and pressure is given this much in ATM. And volume is given in liters. Volume is given what? In liters. 11 liters given here. So when you are given these all things here, what we have to understand now here, formula of ideal gas equation what? Ideal gas PV is equal to nRT, right? PV is equal to nRT. So from this now here, N is equal to what? PV by RT. N is equal to PV by RT, right, ma? So now in this case, after substituting all the values, what we get here? We get answer 0.25 moles. 0.25 moles we get. Okay, so it's about what now here? The concept of calculation of number of moles. Okay, ma? Yeah, next. Next question number 45. The gas which diffuses twice as quickly as SO2 gas. SO2 gas is what now here? Sulfur dioxide. Sulfur dioxide, what is the gram molecular weight? Sulfur 32 plus O2 32. 32 plus 32, 64 gram per mole. 64 gram per mole is what now here? Number of means for gram molecular weight of SO2. Okay, now here what is asked here? The gas which diffuses, okay, as quickly as SO2 is what? So now from gram molecular weights we have to get. First you take gram molecular weight of CH4 as what? 16. Gram molecular weight of hydrogen 2. Gram molecular weight of O2 gas 32. Gram molecular weight of helium gas 4. And SO2 gram molecular weight 64. That you keep in mind. So now here, what is given condition here? R1 by R2. Rate of diffusion of first gas by rate of diffusion of second gas is equal to 2 by 1 they give. So the rate of diffusion of, okay, so twice as the first gas they mentioned now here. That's why R1 by R2 what we have take 2 by 1 we have take ratio. It is given. It is what now? Given condition. Okay. Now generally we know formula R1 by R2 is equal to what? Under root M2 by M1. Under root M2 by M1. M is what your gram molecular weight. Now here R1 by R2 how much is given in the question? 2 by 1 they give. R1 by R2. That is equal to under root M2 is what is SO2. SO2 is what now? 64. Gram molecular weight of SO2 64. By gram molecular weight of another gas M1 you take. M1 is what now here? Initial means what? First gas. First gas gram molecular weight you take M1 here. Now from this M1 is equal to what now here? 16 we get. M1 is equal to 16 after calculation. So now M1 is 16 for which gas in the given options? CH4. CH4 gram molecular weight how much? 16. So like that we got option what? CH4. Okay, man? That is 45. Next, Ansell's alarm. Ansell's alarm is used to detect dash gas in mines, in coal mines. In coal mines, when we are digging the coal, what happens? Some poisonous gas called marsh gas will be released. In coal mines, which gas is released? Poisonous marsh gas, MARSH. Marsh gas is nothing but methane. Marsh gas contains what? Methane. So the marsh gas methane, that is poisonous gas, which is colorless and odorless. No worker in the coal mine can smell the release of poisonous gas, CH4. And also they cannot see. No color, no smell for the gas. But it is highly poisonous. Okay. So now here to detect that poisonous CH4 methane gas, we use what? Ansell's alarm. This alarm will be fitted in coal mines to detect what now here? CH4. That is marsh gas. Remember. Next, 47th one. Uranium 235 gram. It is 235 is what? Atomic weight. Atomic weight of this isotope uranium. and another isotope of uranium is what, 238. So now here uranium 235 and uranium 238. These two are isotopes of uranium. Both have atomic number how much? 92. We know 92 atomic number for uranium, and mass numbers are different here. So the species having the atoms having same atomic number but different mass numbers are called isotopes. So these two are what now here? Uranium isotopes. So they are what taken as hexafluoride, means UF6. What we take here? UF6. So UF6 meaning what? Uranium hexafluoride. Uranium hexafluoride. So in one type of UF6 molecule, we take uranium 235. In other type, we take what? Uranium 238. So uranium will be having same atomic number, but different mass numbers we take here. In one compound, we take 235 here. In another compound of UF6, we take uranium 238. So these two can be separated by the method of what? So here, UF6 with 235 and UF6 with 238. Which is heavier gas? Which is heavier? The UF6 with 238 will be heavier, na? Heavier the gas, less will be the rate of diffusion. Slowly it moves. So the rate of diffusion will be less for uranium 238 than what? Uranium 235. So that's why we use what now? Gaseous diffusion we take here. The process of gaseous diffusion will be used. Which will diffuse faster here? UF6 containing 235 will diffuse faster than UF6 with 238. Remember. Okay. So these are all words known in chromatography, zone refining, solvent extraction. These are all things you will get in the lesson called metallurgy. Metallurgy means what? Metallurgy is the extraction of metals from their ores, minerals. Okay. So that we are going to discuss in next year. Okay. And next, the correct mathematical equations for Graham's law are at constant temperature and pressure. So what are taken constant here? Temperature is constant and pressure is constant. When temperature and pressure both are constants, what will be the formula used for expressing what Graham's law of diffusion? The first one, what is given? R1 by R2 equals to under root M1 by M2 is given. This is wrong. So it is actually R1 by R2 equals to under root M2 by M1 should be there. Next, rate of diffusion of a gas is inversely proportional to square root of vapor density, right? And R1 by R2 equals to under root M2 by M1 is right. Next, R1 by R2 equals to under root D2 by D1 also correct. So we take what B, C, D means third option is right. Next, when N1 and N2 are the number of moles of gases diffused in times T1 and T2 respectively with molar masses M1, M2. So with molar masses M1, M2, when they diffuse in time of T1, T2 seconds, N1, N2 will be what? Okay. So N1, N2 given here, all are given here. Then what? How we can express this Graham's law of diffusion? They ask here. So we know that R1 by R2, R1 by R2 equals to what? Under root M2 by M1. So here R is nothing but what here? Number of moles by what? Time. So R is equal to what? So number of moles diffused in given time. So N by T we take here. So N by T means what? R1 is equal to what? R1 is equal to N1 by T1. R2 is equal to what? N2 by T2. Okay. Then here general formula what? R1 by, this is R1. R1 by R2 general we take here. So R1 in the place of R1 what we write? N1 by T1 we write. In place of R2 what we write? N2 by T2. So that we get what? N1 T2 by N2 T1 is equal to under root M2 by M1 we get. Okay. So rate of diffusion is defined as what? Rate of diffusion of a gas is defined as the rate of diffusion of number of moles. How many moles of the gas diffused in how many seconds? How many moles of the gas diffused in how many seconds is called rate of diffusion. We can take volume by time. We can take what? Volume by time, R value. Otherwise, we can take number of moles diffused by time taken. And also, R is equal to what now here? The change in pressure by time. The change in pressure divided by time also will give R value. Remember. So these all are important areas to understand. Next, question number 50. Dalton's law of partial pressures is not applicable. Is not. So here, whenever this not, does not, this type of questions there, we have to underline what is asked here. So does not applicable. It's not applicable. Okay, it is not applicable to the following mixture of gases at room temperature. Generally, what is the Dalton's law of partial pressures? The total pressure of the gaseous mixture of non-reacting gases we have to take. But here, this is not applicable. This Dalton's law is not applicable to the gaseous mixture in which two reacting gases are taken. So here, generally at room temperature, hydrogen and nitrogen do not react with each other because nitrogen is having triple bond. Triple bond means inert it is. It does not react. And here H2 and O2 also at room temperature, they don't react at room temperature. And O2 and N2 also do not react in the air at room temperature. Only CO and Cl2, carbon monoxide and chlorine gas. These two can be interacting with each other. They can react to form poisonous COCl2 gas. COCl2 poisonous gas will be formed when these two react. That's why for reacting gaseous mixture, this Dalton's law is not applicable. Okay, next, as the at the same temperature, next one, at the same temperature, HCl gas and NH3 gas both are present in two vessels of same volume at a pressure of P atmospheres. So HCl gas pressure what? P atmospheres. NH3 also P atmospheres. In two different vessels, we have taken two gases. When one jar is inverted over the other, one jar is inverted over what? Other jar. So that the two will mix. After some time, the pressure in the vessels will become what? So we have taken two gases in two vessels. Two vessels are having same volume and also having same pressure. When we invert one vessel above the other, what will be the total pressure becomes they are asking. Okay, now here. Now here, vessel of ammonia taken here, vessel of HCl. So one vessel is inverted over the other. One vessel is inverted over the other like this. Now after that, what happens? Now see, first initially take here. Ammonia is gas, generally we know. NH3 is gas. NH3 is a gas. Upward arrow indicates what? Gas. And HCl also what? Gas. Both are gases. When ammonia gas and hydrochloric acid gas, these two vapors, when they mix, we get NH4Cl, which is solid. Remember, NH4Cl is what? Solid. Ammonium chloride is salt, which is solid. Now solid will be formed. The solid will go to what? Bottom now. At the bottom of this vessel, what will be there now? NH4Cl will be there. So after mixing the two gases, the solid ammonium chloride is formed. So the pressure becomes what? Zero. The pressure exerted by solid will be zero. So solids do not exert any pressure. Therefore, we have to take total pressure as what now here. The total pressure becomes what? Zero. Remember. Okay. Because solids do not have any pressure, do not exert any pressure on the walls of the container. Only gases will exert pressure here. Next, which one of the following is not a statement of kinetic theory of gases? Kinetic molecular theory is there, na KMT of gases. According to that, which is not, again see, underline not. If you don't see this not, what happens there? Sometimes you will see this first option, the kinetic energy depends on temperature of the gas. This we know as right statement. It is right statement according to KMT. So immediately you take answer here only. You will feel easy, you will feel laziness sometimes to go to second, third, and fourth options. Sometimes you'll answer here only by seeing. That's why this, whenever this type of questions, not a statement, does not react, does not belong, like these questions, they have to underline not. So what here? Which one of the following is not a statement of kinetic molecular theory of gases? So answer is what now here? The kinetic energy depends upon pressure of the gas is wrong. Okay, the temperature of the gas is right. Temperature of gas is right. Okay, and collisions are elastic, we know. Collisions elastic meaning what? The total energy of the molecules before collision and after collision will be same. So the collisions of molecules are what now here? Elastic in nature. And pressure of the gas is due to collisions of the gas molecules on the walls of container, also right statement. So due to collisions of the molecules on the walls, it will be exerted, pressure will be exerted. The pressure of the gas is not due to collisions between the molecules. Among the molecules, collisions will not exert pressure. Remember, when molecules collide on the walls of container, in that condition only pressure will be exerted. by the gas, remember. So only second option is not statement, not correct statement. So answer is 2. Next, according to kinetic theory of gases, there are no intermolecular attractions. Between the molecules, attractive force is not there. That's why the collisions are elastic. Why the molecular collisions are elastic in case of KMT? Because there are no attractive forces between gas molecules. When there are no attractive forces between gas molecules, the energy before collisions and after collisions will be same. So that point we have to keep in mind. Next one. So for 1 liter flask. So each flask is having 1 liter. Are separately filled with the gases hydrogen, helium, oxygen, O3. Now tell me atomicities here. Atomicity of hydrogen is what? 2. Number of atoms in one molecule, how much? 2. And atomicity of helium is what? 1. Atomicity of oxygen is 2. Atomicity of O3 is what? 3. Atomicities. And what is gram molecular weight of hydrogen? 2 grams per mole. And gram molecular weight of helium, 4 grams. Gram molecular weight of O2, 32 grams. Gram molecular weight of ozone, 48 grams. So at the same temperature and pressure we have taken. Okay, ma? Just a moment. Yeah. So the ratio of the weights of these gases is what? They asked here. The ratio of weights there. Weights means what? No, masses. Okay. Here. Okay. 4 gases taken here. Volume, all volumes are same here. So now number of moles given what now here? So according to Avogadro's law, equal volumes of all gases have equal number of moles and equal number of molecules. This is Avogadro's law statement. According to that here, all are having same volume, therefore same moles will be there. All have same moles. Okay. Next, when moles are same, molecules also will be same. Molecular ratio also will be same. Molar ratio, molecular ratio will be same when volumes are same. According to Avogadro's law. Now number of atoms ratio what? Number of moles into atomicity. Number of moles 1 for hydrogen. Atomicity 2. 1 into 2, 2. And number of moles of hydrogen means what here? Helium, how much? 1. 1 mole into atomicity of helium 1. 1 molecule, 1 atom. Like this, in every molecule, how many atoms are there? Helium, hydrogen 2 atoms, helium 1 atom, oxygen 2 atoms, ozone 3 atoms in each molecule. So atomic ratio we have taken. Next, weight ratio, weight of atoms. Atomic weight. Now 2 atoms here. 2 atoms for each hydrogen, how much atomic weight? 1. 1 into 2. 2 will be there. And 1 helium atom atomic weight, how much? 4. 1 oxygen molecule atomic weight, how much? One atom means 2 atoms are there here. 2 atoms of oxygen. Each atom of oxygen 16. 16 into 2, 32. And here ozone, how many atoms are there? 3 atoms are there. 3 into 16, 48. So we take this one ratio. It is ratio of what now here? Means what here? These 4 gases given. So the option 3 is correct, 54. Next, density of a gas is found to be 5.46 gram per decimeter cube. So gram per decimeter cube means gram per liter only. Decimeter cube is nothing but liter. So gram per liter given at 27 degrees Celsius at 2 bar pressure. I told you once that the density of gases generally will be measured in gram per liter. Instead of gram per centimeter cube, we take gram per liter generally. So now the density of the same gas at STP what? So STP conditions, temperatures are different, and here given temperatures and pressures are different here. So here 27 degrees Celsius and 2 bar. But here STP means 1 bar pressure should be taken and 0 degrees Celsius should be taken. And also we know that temperatures must be taken only in what? Kelvin temperatures. Okay. So the density formula we have to apply here. Now take it here. So density is given what initially D1 value given what 5.46 gram per liter they give. And T1 given 27 degrees Celsius means 300 Kelvin. P1 initial pressure given 2 bar. Right, ma? Next STP conditions. D2 we have to get at STP, and T2 of STP conditions were 273 and P2 approximate 1 bar you take. Okay. Next, what is the formula? D1 T1 by P1. We know that D1 T1, D and temperature. Density and temperature inversely proportional. Density and pressure directly proportional. Density and pressure directly proportional. Density and temperature inversely proportional. Therefore, we get formula about D1 T1 by P1 is equal to D2 T2 by P2. Okay, so on applying, we get D2 is equal to 3 gram per decimeter cube, means 3 grams per liters. Okay, so so this point you keep in mind. Okay. And now next was here. Answer is what now here? 3 grams per decimeter cube. Key might be given wrong here. Don't worry about that. The answer is 3 grams here. Next, the rate of diffusion of gas is 720 ml per minute. 1 minute means how many seconds? 60 seconds. In 60 seconds, how many ml? How many ml of means how much ml of gas is diffused here? 720 ml gas is diffused in 60 seconds. Remember, in 1 second how much it will take, or in 20 seconds how much it will take, we can get it. But the gas diffused for 20 seconds only. So for 60 seconds, if it diffuses, suppose it will diffuse how much volume? 720 ml. But how many seconds it diffused? Only 20 seconds only. So 60 seconds will give volume how much? 720 ml. But in 20 seconds how much will be diffused? That will be answer. Okay. So what it? 60 seconds. In 60 seconds, the volume diffuses 720. In 20 seconds, how much? 240 ml. So option 1 is right. 56. Next, 57. Equal masses of SO2 and O2 are kept in a vessel at 27 degrees Celsius. SO2 gram molecular weight is what? 64, and O2 gram molecular weight 32. That point keep in mind. And 27 degrees Celsius means 300 Kelvin. The total pressure of the mixture is 2.1 atm. Total pressure, P total of gaseous mixture is given. The partial pressure of SO2 is what? Generally, what is the formula for partial pressures? Partial pressure is equal to, partial pressure of SO2 is equal to mole fraction of SO2 into total pressure. Total pressure already given to you. Nothing. So P total 2.1. Okay, is given total pressure. And pressure of partial pressure of SO2 they asked. Now they gave what already given condition, what? Weight of SO2 is equal to weight of O2 they give. Let it be X grams. Okay, and gram molecular mass of SO2 how much? 64 gram per mole, and gram molecular weight of oxygen how much? 32 grams per mole. And also here partial pressure formula, what? Mole fraction into total pressure. So mole fraction of SO2 how to get? Number of moles of SO2 by total number of moles. So number of moles formula, what? Weight by gram molecular weight. Weight of SO2 by gram molecular weight. Like this we get mole fraction into total pressure. So we get 0.7 answer. 0.7 is the partial pressure. Option 3. Okay, that is 57. And 58 is what? Under the same conditions of same conditions, the rate of diffusion of two gases in the ratio 1:4. The ratio of their vapor densities will be what? Okay, so rates of diffusions given 1:4. The rates of vapor density. What is the formula? R1 by R2 equals to under root VD2 by VD1. R1 by R2 equals to under root VD2 by VD1. This formula we had applied. Then we get 16:1. Next, 59. Hydrogen chloride gas is sent into 100-meter tube from A end and ammonia gas from the other end B under similar conditions. The distance from A where two gases meet is what? So now you see, listen, here tube is given this one here. So here HCl and NH3. And NH3 will be moving faster than HCl because here HCl gram molecular weight 36.5 and NH3 gram molecular weight 17. So lighter gas will diffuse faster. That one keep in mind. Now total length, let it be 100 meters. And X will be this distance traveled by NH3. And 100 minus X will be distance traveled by HCl. Okay. So what is the formula here? L1 by L1 L2 by L2 T1. Why again here R is equal to L by T we can take. Length diffused. Length by time. Length by time also will be equal to rate of diffusion. So in place of R, what we can take here? In place of R, what we can take? L by T. So L by T means what? Length diffused by time. So L by T we can take here. Okay, ma? So L by T if you take now T in seconds. T in seconds, length by time. So like that we get what? L1 T2 by L2 T1. That is equal to under root M2 by M1. So from this we get the length of what here? Ammonia gas diffused is X. Length of HCl diffused is 100 minus X is equal to M2 by M1. that is equal to 59.43 meters what x. Then 40.48 will be HCl diffused. So option 1 will be right answer. Okay, next, last one. Among the following gaseous elements with atomic numbers which will be having higher rate of diffusion. So what are the gases given? Nitrogen here. What is this? Nitrogen. Atomic number means N2. Gas we have to take here, remember. One N2. And here O2. It is what now? O2 we have to take. Molecule we have to take, remember. The gas means molecule we have to take. Now here Z, neon. Neon means what now? Ne, that's all. Ne2 we don't write now, only Ne we write. And 17 means chlorine. Chlorine means what is this here? Cl2. Cl2 gram molecular weight, how much? 71. 71 gram molecular weight, 71 here, gram molecular weight 20 here, gram molecular weight 32, gram molecular weight 28. So which will diffuse faster? Whichever is having less molecular mass will be faster, will be diffusing faster. So here neon has how much here? Only 20 gram molecular weight, gram atomic weight. That's why less the weight, greater will be rate of diffusion. Okay, ma. Bye. Good day. Take care.